Okay. Okay, I'll just say welcome everybody. My name is Melissa. I'm an academic advisor here at the Faculty of Engineering and Applied Science. Today, Adam is going to be running this whole session, and we'll take it to you, Adam.
Great. So I will just start sharing my screen here, and we'll do our kind of intro presentation. Oh, that's not right. Small screens. There we go. All right. So this presentation is, of course, called "What is Engineering?" Kind of a very, very brief intro to what is engineering, and the vast majority of the presentation will just be working through an activity, because I feel like the best way to learn what engineering is to just do something related to it. So, oh, these slides are animated. I did not know. Okay, so what is engineering? Basically, we're doing systems engineering at the University of Regina. And systems engineering is kind of distinguished from the more traditional engineering in that we're really thinking about systems as a whole. So, you know, I'm in software systems engineering, so I'm dealing with software systems. And so that's, you know, anywhere that a, piece of software might run, a computer program or an operating system. And so in your mind, you might just be thinking, okay, so that's like desktop computers, but you don't have to think very long before you're like, okay, well, it's also mobile phones. Then you might be thinking of like, well, game consoles. And then you might even think, well, I have a smart TV that's got software in it, or maybe a smart fridge, or all sorts of different places. And so when we're thinking about systems engineering, we're really trying to think about, these systems we're designing, a little bit of the hardware and the software. And, it takes a lot of people to put together a system like this. You're going to have people who are focused on the software. You're going to have people who are focused on the hardware. You're going to have business people. You're going to have maybe people from the arts who are, writing things or doing graphics or whatever it might be. So big teams of people all working together to create kind of a cool system or product. And we don't just want to be thinking about this product in terms of making something cool and getting it out into the world. We also want to be thinking in terms of, once this thing is out in the world, what does that mean? Because, this thing is going to break down at some point. And so people are going to need to maintain it. At some point, this thing's going to need to be disposed of. And so what's going to happen then? We really don't want to be creating things that we don't have a good end of life kind of solution to what we're going to do with it. So yeah, systems engineering is all about considering the entire life cycle of these systems from the beginning all the way to the ending. I am highlighting, well, I guess we have resource management as well as part of this. What things do we need to come into this system to make it, to complete it, right? So I'm highlighting two types of engineering that are done at the U of R, electronics and software. But we also have industrial, environmental, and petroleum, and a couple other flavors at the grad level as well. So electronic systems engineering is really more of a focus if you're thinking computers, it's more of a focus on the hardware, but it doesn't just have to be computers. It could be really any electronic components. And so the idea here is we want to really learn and study these systems and the electronic components that make them up. So you'll do kind of a little mini electrical degree where you learn all of the electrical side of things, about voltages and currents and power and not destroying your computers and your systems and that sort of a thing. And then electronics sort of specializes into some specific fields like control systems, telecom. So that'd be like working for SaskTel and working on their wireless and wired systems, power systems, actually getting high voltages to people's houses to power all their everything, basically. And microelectronics, which is more like computers, that sort of a thing. So there's a ton of stuff there in the electronics program. And again, just like with software, they're thinking in terms of systems, right? So these systems you're building, what goes into building it, how is it designed, how is it built, how is it maintained, and what happens to it after the end of its life. So yeah, electronics isn't really my focus. My focus is more of software. So software, the idea is, we're really focusing in on the software. How do we design and code up computer systems to solve specific real life problems? And again, from a systems approach, right? So we want to think about what the problem is we want to solve. And, in software, that really means working with users one-on-one, talking to them, interviewing them, learning what their pains are, what problems they have with existing software, or maybe that we could use software to solve. Then we get together and try to design something which can solve that problem. We want to, again, get into the hands of the user as soon as we can to see if it actually does solve their problem. And then we want to test it, make sure that it's working reliably and consistently in the real world. Definitely a big part of software engineering is the ethical or moral component of designing these systems that, might have pretty big impacts if they go wrong. If you're designing software for something like a big piece of equipment or a plane or something, and that software bug, if that software had bugs, it could lead to that system failing and some kind of a crash happening. So, and not like just a computer crash, but actually like a, real crash. So a big part of software is software engineering is testing your software to ensure that nothing is going to go wrong with it. So that's what we do in software engineering. And there are all sorts of projects that students work on. For example, in the capstone this year, we have students who are working on a few different types of web applications. We have people who are doing machine learning to try to classify photographs. We have one student doing machine learning to try to find similar songs to each other and basically help DJs to find songs that sound good together so they can swap tracks back and forth. I don't think we have any games this year, but often we have video games, and that's one of my areas of specialty. And indeed, the activity I have planned for you today is going to be game related. So that's software systems engineering in a nutshell. Some of the things we do, some of the things you might do if you get involved and join our school or any other engineering school. You'll likely do similar types of things. So the rest of today, we have an activity planned. Please ignore all my lab stuff. I have a link to send you through chat. Basically, this is done just like a software engineering lab would be done. So you're going to get a link to a lab document. And I will again send this in chat here. This is just a document I have hosted on my GitHub. And it's going to walk us through making a simple game in a service called Make Code Arcade, which is hosted by Microsoft. It basically allows you to write in your computer browser, code up a simple video game, kind of a little low resolution pixelated environment. And there's a few different programming languages you can use to get your game going. Some of them are more high-level things that experienced coders will do, and one is a really low-level drag and drop blocks together. So that's what I thought we would do, as I didn't know the level of coding experience the different people who show up today might have. So yeah, we'll just do these drag and drop blocks to make it work. So yeah, Microsoft Make Code Arcade is the name of the website. I have a link to it right under Getting Started. You can open that up in a new tab and it will take you there. This is the landing page where you can start a new project. And I actually have some starter code for, and in my doc, these are just images. Might be kind of strange, but Make Code Arcade saves its projects in images. So if you save this image, do like a right click and save as if you're on Windows. I'm not sure what the equivalent would be on Mac, but there's some way you can save this image to your computer. Find the place that you saved it. So I have it saved here in my documents, arcade lander start. And then if you drag and drop this onto the make code thing, it will load up the file and we'll be ready to go and get coding in it. So the game I want us to make today is kind of a simplified variation of Lunar Lander. Lunar Lander is a 1979 Atari game where the player pilots an expensive space probe and lands it onto a place on the moon. And of course, if they're even remotely going too fast or not aligned just right, the lander will crash and explode, and you'll get some snarky message printed to the screen saying how you just wasted millions of dollars because you crashed your lander. So we're going to try to make something kind of like this in Make Code Arcade. You can get the final version of the project here on this second image. I don't know how far we're going to get. I have a strong suspicion we're not going to make it through the entire thing, but the lab doc is really well guided, so you should be able to keep going wherever it is we have to stop and finish off the project yourself. You can also grab this file, save it to your computer, and drag and drop it in to see what the final version of the code will be. In the upper left here, you have a little simulator for the game where you can move your little probe around. My probe is just a simple green triangle. You can make a nicer one as we go today. And then we want to land it onto the little landing zone here, and it will tell us how much fuel we have left. So that's what we're going to try to code up today. Again, you can take a peek and see what the final version of the code is. But yeah, we're going to start from the starting place and talk through what we're doing, why we're doing it, that sort of a thing to get our very simple starting place to this final version. So yeah, I'm going to go back and grab the starter code and drag it back in to Make Code Arcade. So we're going to be coding using these blocks. And basically what the blocks are is they represent lines of code that you might type into the computer in a more traditional programming, but they're very visual. You can drag and drop them around. You can quickly see all of the things that are available to you by clicking into the different menus here and then dragging these in to the screen and then just locking them into where you want them to go, that sort of a thing. So yeah, what we'll be doing is basically dragging around blocks, dropping them into our program, and then maybe changing some settings on there here and there to kind of fine tune the behavior of these lines of code. If ever you want to see the code side of things, you can always click over to JavaScript or Python, and it'll show you what the coding calls are like. But like I say, we're going to try to stick around into the blocks, a little more visual, a little more beginner friendly. It takes a little bit of time to switch back and forth, and it may mess up all your blocks if you switch up back and forth as well. So you might just need to drag them out. So yeah, don't recommend doing that. So yeah, at the starting place, I've given you just a little bit of code, not too much. At the beginning, we're setting some kind of game parameters, and we'll talk about these a little bit as we go. We're creating our game world as well. So we have a sprite for our game character. You can click on that here, and that's my nice little green triangle. I was trying to do like the Atari Quadrascan, which is just green lines or white lines or something. But you can draw something better in here as your player if you want to fill something in. Maybe actually make it look like a lunar lander probe. I kind of like the green triangle personally, so that's what I'm going to stick with. And then you can hit done. There's also a little bit of a level you can click on here. And so far, I've just kept it pretty primitive, flat. We have a landing zone and some arrows pointing us towards our goal. So yeah, we'll for sure get to the point where we're making a better level today. I am convinced of that. I don't know how far we'll make it, but I think we should make it that far for sure. Every time you change something, you should see it updated in your little simulator in the upper left here. So yeah, So what do you need to know about code? Well, when you're programming a computer, basically baking or creating something, and there's kind of two parts. There's the ingredients that you need to sort of make your recipe. And there's also like the order, the set of operations you need to do in order to kind of have your food turn out right. You need to do certain things in a certain order. And code's kind of the same way, right? So basically, we're going to try to solve a number of little problems. And each time in solving those problems, we need to be thinking in terms of, okay, so what is the ingredient I need to solve this problem? And in what order do I need to do these things to solve the problem? And so it kind of stands to reason that you have to do some things before other things. Like if you need to if you need to use it, if you try to use something for computer programming is really a lot about learning these basic things you can do and then figuring out what order you can do them in to accomplish your goal. So there's a few different places in game programming in particular, there's a few different places that your code can start. One of them is called on start. And these are the things that happen when your game first starts up. So when we first load into our page, all of these ingredients, all of these lines of code are going to be run in order on start. So right now I'm just setting up some game parameters, which we can see down here. I'm creating our ship and I am creating our level, and that's it. So anything else we want our little baker to do when the game starts, we need to put in this on start function. In games in particular, there's another place that code runs, and that's every cycle that the game plays for. And that's called, the place that happens is in this one called on game update. Now, I've given a few little functions that I think are a little bit too tedious for you to code yourself. One of them I already have wired up to in-game update. But we'll be creating some more of these as we go. So yeah, one of the big challenges in game development is to figure out, okay, so is this something that should happen when the game starts up? Or is this something that needs to happen every cycle that the game plays? And beyond that, it's just figuring out these little problems we're going to try to solve and solve them. And so one of the first problems we have here is that, if you remember from my demo, at the beginning, our lunar lander should be falling. There should be some gravity in this world, right? It should be causing the lunar lander to be falling. And so that's our first problem we want to solve. And so basically, we want to apply a velocity in the downwards direction to our lander every cycle that the game updates. So that's one of the first things we want to do. Actually, I might be going a little different than my, I might be doing that a little bit differently than my lab doc. I'll try to stick to my lab doc instead so that we're all on the same page. So something else we may want to do as a starting place is when we move our buttons, our arrows here, we might want our player to move around. So let's actually start there instead. So what we want to do is basically check every time the game continues to check if a button is pressed. And so we can do that so this is something we want to do every frame the game plays, right? So this is something that should be happening in our on game update function. And so we want to add a new block to our on game update, and we want to add an if block. So I opened up logic here. And at the top, we see this if true then block. So we want to grab that and drag it onto our board. And we actually want to clip that into the on-game update. So what an if block is doing is basically saying, if some condition is true, only then do we want to run whatever code is in here. So we may want to run some code whenever a button is pressed. So we want to change this true to being if a button is pressed. So we need to find a block that is like one of these hex shapes, these kind of hexagon, long elongated hexagons that correspond to a controller button being pressed. And so as a hint, that's inside a controller. Then we want to look for one of these hexy shapes. So if a button is pressed, that's what we want to grab. So we want to grab that and then drag it into the true function. So if a button pressed, we don't actually want the a button. We want our well, let's start with up. Let's start with up. So if up is pressed, we want to do something. So let's grab this drop down and set it to up. And so now any code we put in here will play whenever the up button is pressed. Now a good, and we might want to do multiple things that all happen if our up button is pressed. So a good kind of best practice in programming is to call a function when this is pressed. Function is kind of a bunch of blocks or lines of code that are all grouped together that happen in a certain whenever it's called. So maybe we should do that. Maybe we should create a function too. So we're going to have to do a little bit of setup here before anything cool happens. So just bear with me for a bit as we do some setup. So let's head to our functions and go make a function. Again, so that was in functions, make a function, and let's name our function by typing in here, up input, save that. So yeah, this is like a little block of code, a grouping of code together. And we only want this code to run if this button is pressed. So we can make sure that happens by kind of linking our code here to this block by doing what's called a function call. So let's do a function and this one called call up input, and let's snap that in here. So now if the up button is pressed, then we're going to do our call input, and this code here is going to run. So what do we want to do if our up button is pressed? Well, let's just finish off our input handler. So there's like 3 buttons we care about, up, left, or right. So we can copy, actually, let me pull out this before we copy it. We can copy this if block by doing a right click and hitting duplicate, and then let's snap that in and change it to left. We can right click on this again, duplicate, drag it in, and click it to right. So now we have a little if block for each of these. We probably want to make a function for each of these as well, just for best practices, keeping our code kind of straight, easy to understand. So yeah, we'll do the same thing. We'll duplicate our up input and rename it to something like right input, and we'll duplicate this one as well and call it to something as left input. And we are going to want to call a function in each of these that I guess in our if block here that triggers one of these functions. So again, we can duplicate this one. Can we change it? No, okay, so that's not a good way to go. Let's not duplicate it. Let's instead go to functions and then do this one, call right input. And then let's go to this one, call left input. And now we want to do something to see that these inputs are firing. So before we do any physics stuff, let's just maybe play an effect to see if they're firing. So what we could do is we could go to sprite, and then we want to do we want to start a spray effect. And we can drag that into our up input and change our my sprite. And we want to duplicate that for each of these. So that means when we push any of these buttons, our ship should start making some sparks. It might take a sec for our game to restart, but we can test it. We can push up or right or left, and we're making lots of sparks. But they don't ever go away. So we also need to clear them if none of these buttons are pressed. So I've started a function for us here as well called check clear effects. I don't know why I left that in, but we can use this to clear any effects. So we need to drag in another block. It's in sprites, and it is clear effects on my sprite. We will change that my sprite to ship. And then again, we have to call that at the end here. So we're taking a little bit of time to set everything up right, but I think it's worth it in the long run. It'll make everything a little bit easier to follow, I think. So now we can again test it. Now if we push up or right or left, our ship will start making some sparks. And when we aren't pressing any of those buttons, it should clear the effects. Oh, actually, my logic is a little bit off here. Just give me 1 sec to check my notes, because right now this is being called all the time, right? It's being called whichever button is pressed. It's trying to start it, and then it's immediately coming down here and turning it off. So that's not what we want to do. So really what we want to do here is we want to check to see if none of these buttons are being pressed. Then we want to clear our effects. So we could do this using these if statements where we kind of chain a few of them together. So we want to check if not up is pressed and not left is pressed and not right is pressed. And I thought this was maybe a little bit of tedious coding for you. So I gave you this one here. You can look at it towards the bottom here. It basically just says, well, you can just read it right to left, or left to right, I mean. If not is right button pressed, and not is left button pressed, and not is up button pressed, only then do we want to do this thing where we turn off our effects, right? So we can do our check clear effects then, and that will turn it off. So now if we push down the button, we'll start spraying. If we let go, it'll let go. So basically now we know that our buttons are working, but we're not really doing anything cool yet. So the next thing we want to do is start applying some physics to our ship so that, when it first starts off, it might be falling. And then if we apply basically our thrusters in either the up or left or right, we'll fight gravity and move around a little bit. So the first thing we want to do is apply some gravity to our ship. And I've given you a block for this as well. It's this one that says change v_y by gravity. So we need to figure out where we want to call this. So I think this probably would make sense to get called, could be here at the end of on game update. I also have given you the starting of a function called physics somewhere. Yeah, this one up here. So maybe instead we should call it in physics. Let's bring it up to physics. As you drag things around, yours will end up in different places than mine. So maybe just take a peek around and see if you can find physics. Put that one at the top. And then we need to make sure we're calling physics in our game update as well. I just have some other little functions in here that actually move the ship based on these variables and slow down our ship, kind of like a friction function is in here as well. So yeah, we want to make sure we're calling physics. So we would do function, call physics, and drag it to the bottom down here. And it'll take our game a second to update. And we should now see that our ship is falling through the bottom of the screen. So that's cool. Gravity is working, but that's not really that useful. We want to be able to fight gravity by turning on our thrusters too, right? So I have again given you a couple of functions here for doing that. One for changing velocity x in a negative direction, one for changing velocity x in a positive direction, and one for changing velocity y in the negative direction. So the way that our game world works is it's kind of like in math where you look at the coordinate plane, you've got your axes, that type of an idea. In the lab doc, we've actually made it through the user input part. We are now just starting into functions. So I've drawn this quick diagram for our functions, or for our world space. So this is our x-axis, and this is our y-axis. And right now, our ship is falling downwards in the plus vy. So we want to, if we press down up to move our ship up in the negative vy, if we push down left, we want to move it kind of in the negative vx. And if we push down right, we want to move it in the positive vx. And so that's basically what I've given you, three line calls that should do that. Just need to figure out where they need to be called. So what's the situation or what's the condition that should make the ship try to go up? That's if the up button is pressed. What should make it try to go left? That's if the left button is pressed. And you should try to go right if the right button is pressed. So back in MakeCode, that's these three functions. are Vx negative, Vx positive, and Vy. So we just need to figure out where to snap these in. So Vy positive should go with our up button, right? So we want to drag that into our up button here. Vx, so that's easy, right? There's only one button that would be in the Y section. Left and right are a little bit more tricky, right? Because they're both in the X direction. But one is set up to 0 minus our thrust value, and the other is plus our thrust value. So the minus one, we can again look at our diagram. That's going to the left, and our positive one is going to the right. So we want to lock in our negative one into the left input and our positive one into the right input. Now our game should restart here and push up. We should be fighting gravity a little bit. And then we stop pushing up, it lets go and gravity kicks in. We can also move to the left and move to the right. So you can play around and see if you can keep yourself in the frame. Cool, so that's all well and good. But eventually our ship is still falling off the screen into the abyss. And we don't want that. We actually want to track our ship around the game world. Because remember I showed you that we have a game world in here early on. When we clicked on this tile map thing, it showed the game world here. So our ship is starting somewhere up here and falling down off the screen to its death. And we don't want that. We want to track where it goes. So in game development, we call our screen a camera, and we just want the camera to follow our ship. So we can hop into the scene variable here and look way at the bottom, or the scene thing here. Look way at the bottom, camera follow sprite, my sprite. We want to click that into on start, and we want to change my sprite to ship. And now when this restarts, it doesn't look like our ship is moving, but it is, right? Now the ground comes to us and we eventually hit the ground or probably fall right through it. Yeah, we fall right through it because we actually need more game code to crash our ship into the ground. So yeah, that's kind of the coding process, right? You figure out one thing you want to solve, and you write a little bit of code to solve it. And of course, in doing that, you discover more problems that you need to solve. And then you want to solve those problems next. So a problem I'm seeing is that our world is super boring. So maybe let's take a break from doing code and do some level design instead. So if you click into your tile map one here, you can see our world. It's pretty boring. Let's try to make it less boring. So you can, this is kind of like a bunch of little tiles that we're drawing into a bigger world plane. So if you drop down this forest into dungeon, that's the one I was going with. These kind of purple little bits of soil, to me, look like a space world, you know, maybe the moon or something like that. So we can just drag them in and, I don't know, build a mountain or something kind of interesting here, slightly more interesting. Make sure you include your goal somewhere. Don't want to draw over that. So I'm just going to leave it where it is. If you want to, you can put some outlines on your world as well. But that's really up to you. Just something that represents a world that our ship can fly around in. That's a little bit more interesting. Maybe has some obstacles we might crash into. These little guide things I made, the arrows that are pointing towards slow, you can find those in my tiles, and they're all there. So you might want to draw some arrows so that when the player is falling, they kind of have an idea where to go to get to their goal. That way they're not just hopelessly looking around, trying to get to their goal and never getting there. Yeah, so that's a very simple level design. The other thing we need to do is we need to tell the game that these are things we're going to crash into. And we can do that by painting these as walls, by clicking on this, kind of wall looking icon here, and then just painting all of these as red. And this basically lets us select all of these tiles in our code and then do something when the ship crashes into them. So we want to do this for all of the tiles except for the goal tile. Something like this maybe. Don't want to do it on the goal tile because that's not considered a crash. That's considered a win, probably if the user gets their lander to that spot. So yeah, I'm happy with this. I've kind of made a couple little mountainy looking things. And I've colored them all with red paint, except for the goal space. So good, let's go to done. And our game probably will take a sec to reload with the new world popped in. But yeah, now we can see our ship is moving around in our world. It still isn't going to be crashing into the walls yet. That's another bug. Oh, it's just stopping when it hits them right now. So that's not really what we want to do. We want it to crash if it hits them, not stop. So that'll be the next thing we fix, is that we want our ship to crash when it hits those walls. But yeah, we're doing better. We've got a slightly more real interactive world. Our player isn't just falling through things. So that's kind of cool. So how do we cause our ship to crash into the wall? Well, this is another one that's in scene. And we want to hop down till we find, this one. On sprite of kind player hits wall at location. So this is kind of like another function. It will run anytime this condition happens. So anytime our player hits a wall at a location, code in here will run. So what might we want to do if the player hits a wall? We probably want to tell the player that they crashed. So we can do that by going to game and then doing there's a term called splash, which is kind of like a pop-up. It signifies something to the player. And we can type into there, you crashed. And we probably want to restart the game as well afterwards. And that's just also in game and then reset game. So now when our player hits a wall, they'll crash, it'll tell them, and we'll restart. So that's a little bit better. Yeah, we'll crash and it'll say you crashed. And then restart. No real penalties, no real game over, anything like that. So the last thing we need to do to get kind of a minimal playable product, minimum viable product, is have something happen when the player lands on the goal condition, because right now they're still falling through and then crashing on the red we drew earlier. So again, we can do another one of these kind of teal blocks that checks if our player has arrived at the destination. And if so, run some more code. So this would be in, again, scene. And this one's a little bit longer. It's on sprite of kind player overlaps at location. So we want to drag this in anywhere. Now this one we have to set the sprite, set the tile, that's our goal. So we can click on this thing and it'll drop down all the tiles we've used in our world. And we know that our goal is this kind of up white rectangle bit. So we want to click on that thing. So now when the player overlaps with that, we want to do something. So we could just tell the player that they won and be done with that. So that would be in game. We can drop in game over and flip it from lose to win. And that's all well and good. So now we can restart it and get our player over to the goal. And they hit that. And it says you won. So hey, that's kind of cool. But if you've ever played the actual lander game, you know that a big part of it is landing very, very, very slowly. Because these landers are, very fragile things, It could be very easy to break off a leg or something if you're landing too fast. So we want to make sure that our player is only going very, very slowly. And back when we were controlling gravity, which was, where was that? That was this one where we said change v_y by gravity. So v_y was our velocity, and we wanted to change that by gravity. So we want to make sure that v_y is a very small number. So we can do that with more logic, and then another if block. So we want to do an if block in here, drag it in. Actually, let's scratch that. Let's not do an if block. Let's do an if else block. So that's this one that has the two little slots in it. And so we want to set our win condition in the little hex thingy. So we would want to go to variables. Maybe not. We would want to go to logic. That's better. And we want to do a comparison on it. So we want to grab this first one that has like a number and then an equals and then a number. We want to change this equals to a less than sign. So if something is less than something, then we want to run code in here. Otherwise, we want to run different code. So as I mentioned, our speed was called v_y. So we can drag that into the first number. So if v_y is less than, and now we have some other numbers. So what's the maximum speed that we'll say is a safe landing? So I've set another constant up here called max win v_y. I set it to a number that I think feels about right. It works pretty good. So you can find that one in your variables, max_win_vy, drop it to the other one. So yeah, if your speed is less than that, that means you're going slower than that speed. So that means you're braking pretty good, right? You're going pretty slowly. So in that case, we'll call it a win. Otherwise, we basically want to do something similar to our other crash state. So we want to copy our splash and copy our reset. But rather than saying you crash, maybe we want to give the user a little more info to know that you have to be going very slowly to land. So you could say something like slow down to land safely. That could be our message. And now we just want to test this out and see if it's working. So if we take our lander and bring it over to the landing zone and we're going fast, we're still going to crash. They're going to say slow down to land safely. On the other hand, if we're going slower, so you'll have to keep kind of hitting the up button to kind of brake yourself a little bit, go really slow, really slow. And now we win if we land safely. And that's a big part of this lander game, just slowing down enough that it's considered a safe landing. So we have a working game. There's one extra feature that we could add to it as well that we have in the final version, and that's like a gas system. So our lander only has so much fuel. It needs to use that fuel to engage its thrusters, whether it's trying to go up or go to the right or go to the left. And if it runs out of fuel, it can't use its thrusters anymore, so it's going to start falling really fast. So that's the last thing we want to do. It's a little bit more complicated, I think, than anything we've done so far. And I kind of left it like as a challenge as well in the lab doc. So if you scroll way down, we built our level, we've set our collisions, we've got our win conditions, we've got our lose conditions. Here's where the adding some fuel stuff starts. So we need to do a few things. We need to add like an energy bar to the player that slowly decreases as they lose fuel. We need to set the kind of maximum value of that energy bar to another constant called max fuel. We need to attach it to our player so that we can see it falling around. And these are all in the start function. So let's just do these really quickly. So I think these are all in status bar. So we can do status bar, this top one here, and put this into start. Come way up here to start. And so yeah, we want to create a status bar. We want it to be width 20, height 4. And we want to change its kind to energy rather than health. Energy makes sense, I think, as fuel. That's probably the most similar type. What else? We need to do max value is called max fuel. So that's again in status bar. Set status bar value to 0. So we want to set status bar max to, it's called max fuel. That's in variables, max fuel. We want to set our, what's the other one? Another set status bar value to max fuel. So this is basically just kind of setting up the maximum value that our fuel has. and the current value that our fuel has, right? So it has a maximum amount, and then so like that's the size of the gas tank, right? And then as it runs, it'll use up fuel from that gas tank that will trickle down until it eventually runs out altogether. So both of these are going to start at the maximum amount, but it's going to decrease over time. And then we want to attach the status bar to the player. We want to attach it to my sprite, and it's called ship. And I think that just puts it right in the middle to begin with. Yeah, so we can see it or just kind of on top, right? So we actually want it to be, I don't know, not overlapping with it. So if we click on the plus thing here, that brings our little offset. And what do I have in our notes? I have -25 for padding, works to make it pretty good. So you just need to type that into the block. And that will have your status bar be underneath. Cool. So again, we've created a status bar, but it's not decreasing as we use our fuel. So that's no good. So now we want to decrease this anytime we're using our fuel. So again, let's check in our lab doc to see what that is called. It's change status bar value by -1. So we need to do that somewhere. So status bar, change status bar value by -1. So where should this happen? I'm thinking this should happen anytime the player's using fuel, right? So if they're pushing up, or they're pushing left, or they're pushing right, I think we should be decreasing fuel. So we could put this in this if block here, but remember, we made a special function for each of these. So we should maybe put it right in the function for each one. So in our up function, and then in our left function, we can just right click it and duplicate and bring it down to this one. And in our bottom function, right click, drag it down. And now we should be using some fuel up as we move around. Cool, so we're getting closer. So we could just keep going till we run out of fuel. But we should be noticing another bug. Running out of fuel isn't giving us any consequence yet. You know, we're still able to move around. So again, we found another problem. We want to solve it. So how do we check that if we're out of fuel, and if we're out of fuel, not let the player move around? So if we're out of fuel, your mind should be thinking, okay, another if block. So let's go to logic, grab an if block. We want to check if we're out of fuel. So that's like one of these comparisons. If some number is less than some other number, or maybe even equal to some other number, could be 0. So we could do like a logic, an equal. So we want to find out if our fuel is equal to 0. And we can grab that from status bar dot value. So grab that in, whoops, status bar dot value. So if our status bar dot value is 0, then we're out of fuel. So what do we want to do then? Well, we don't want to be able to move then. So let's just think about this logic. So if it's 0, we want to not move. We already kind of have like positive logic here where we already move if a button is pressed. So we want to change this if to be, you know, what's the situations we can move? And so one way that we could do it is, what if our status bar value is greater than 0? That means we still have some fuel in the tank. If we still have some fuel in the tank, then we want to be able to move. So that's what this if block is doing. If there's still some fuel in the tank, we can move. So we can drag that into our game update and then nest each of the button presses inside of there. Move our check, leave that there. One of the problems with nesting is that things tend to go inside of them where they might not want to. So let's just, let's look at what we have all together now. So we have, if we're out of fuel, then we want to block against any of our movements. Not sure where this one should go, maybe here. Because if we're out of fuel, we also want to turn off the effect too. So we might need one more if statement for that. We might need an if statement for if we're out of fuel, we should turn off our effects as well. So yeah, we could do one more if block, if true, and put it at the bottom here. We want to do another comparison. If I don't know, something is less than something. Oops, we don't want that one. We want circle is less than circle or equal to circle. So if our fuel is equal to 0, which is our status bar's value, then we want to duplicate this clear effects and toss it down here. So we're almost there. We can check this now. When we test it, if we run out of fuel, we should stop moving. It should lock us out of our controls, basically, and our ship will have no chance but to fall to its eventual. Got a little bit of gravity or a little bit of momentum, but then gravity kicks in and we'll eventually fall and crash. Cool. So I think the last thing to do is, if the user lands safely, we should tell them how much fuel they have left. That's kind of like a high score, right? Then every time you play it, you can try and get slightly more fuel. So that would be cool. Unfortunately, that's a super duper duper long call. It's all of this stuff. So I gave it to you as well. We can tack that into our win conditions. So yeah, if the player wins, we just want to print to the screen how much fuel they have left. So I dragged and dropped that in. Now if we land safely, and we got to go pretty slowly to land safely, it will tell them how much fuel. Oh, I must have some mistake here. Yeah, I'm not sure what my bug is here, because it should be a greater value than this. Let me just get rid of this round block and see what happens. This is very typical in programming. You do something that you think is going to work, it doesn't work, and then you just need to try to figure out what went wrong, and kind of one by one, one thing at a time, try to solve it. Yeah, so I should be timesing my fuel by 100 first, because it's a percent. So that's what I did wrong. So should be taking all of this here, timesing it by 100. Multiply by 100. Drag this thing into here. Fuel divided by our max fuel times 100. And we want to round it. Then we want to drag it back into here. Let's try this one last time, and hopefully it works. Oh, I'm not a good pilot. I'll slow this thing down. Okay, so now we have something slightly more real. Try and get slightly more fuel in it. It's much like what software engineering is. You might be working in different problem domains. Games are purely for fun, but a lot of these same things can apply, whether you're building systems for e-commerce or the web or medical or whatever it might be. All sorts of cool things you can do. The other really cool thing with this make code is you can actually do some hobbyist electronics projects too. So this is the electronics pitch very briefly. So if you click on download here, they show you all of the different little electronics projects you can build that can run your game. There's a lot of cool ones where you actually get to watch. And I think that's super cool as well. So that's the tiny little electronics pitch, because I'm more of a software person than an electronics person. But if you did build one of these, you could load your game to it and kind of see the whole software systems. So that's the systems connection. I myself have not built one of those yet, but I did something else that I thought was kind of cool. On my camera, if you can see it, I managed to get my game running on my Nintendo Switch. So that was my systems thing that I did. I can't see my video, so I can't see if I'm in the frame, and you can see this. Yeah, I guess you can kind of see it there in the frame. So that was my as close as I could do to electronics. So yeah, that's software engineering, or a small part of it, coding up a game. Hope you found that interesting. And I guess I will turn it over to Melissa, if you are here, to do your final.
Yes, I'm here.
bit.
Thank you very much. Does anyone have any questions? That was a lot of information. Oh my goodness. Okay, so what I'm going to do is I'm going to share my screen, and just let me just go and just talk about, there it is. Okay. Admission requirements. So early admission is coming up pretty quick. It's March the 15th. And from grade 12, we need a 70% average. The 4 classes that we look for when you're applying is that English language, class, pre-calculus 30 or calculus 30. Calculus 30 is preferable, but we do accept that pre-calculus 30 as well. Chemistry 30 and physics. And that's it. Admitting, you would go through the admissions website, and yeah, it's that easy. Now, Caitlin, if you unmute yourself, you said you were from Moose Jaw, right?
Yeah.
Yeah, and you're in grade 12?
Yes, I am.
Oh, okay. And why are you interested in engineering?
It's always kind of been like around because my grandpa is an electrical engineer.
Okay.
And yeah, and then one of my teachers thought that it would be a really good thing for me because I thrive in like maths and sciences a lot. So
Good.
yeah.
Oh, your grandpa was an electrical engineer.
Yes.
That is really cool. That is good. Yeah. You have any general questions?
Not really. Do you know about like the next semester, how it's gonna look at all or anything? Or are you guys just kind of waiting?
Well, we do know for sure that spring summer will be online, but you would be starting in the fall. So we're still waiting, I think, for an official word yet, whether classes will be face-to-face or online. So don't know yet for sure about the fall.
Okay.
Yeah.
Yeah, that's the only question, I think.
Okay, great. Well, thank you for joining us today. And Adam, thank you for your programming demo. And that's it. We'll wrap it up. I'll turn off record, and we'll see you, everybody.
Bye.
Bye-bye.